Hello, everyone. So this is the third assignment in our function trig unit. And this assignment is going to focus on how to come up with the equation of a sine or cosine graph given a minimum and a maximum point. So that's important that you know a minimum and maximum. And our final assignment, which will be on Friday, or actually Monday, will be on the application side of function trig, where you have to come up with an equation, generally not unit circle based, of a situation, a sine or cosine equation. So it's important to hear me well right now. If you are doing a sine equation, and I'll say to the left of f of x, remember f of x is just y equals what I want you to do. You can do sine or cosine for any wave because they're really the same thing. It just depends upon, the value of h, actually. So the a, the b, and the k are the same in sine or cosine. It's the h because h shifts left and right. And so it's one's just to shift to the other. So if you're doing a sine graph, you have to do the h sub sine calculation, not the h cosine. It's a little easier to do cosine. You'll see how that works. So I need to write this point down. This will be pi 1. Now, why did I pick that? Because we need the minimum to be to the left of the maximum. So pi over 2 negative 1 is the x min, y min, and I'm going to write them in up here. And then the x max, y max is pi 1. It's important, people, that you get that correct. And then the calculation of the period will have to come at the end because that's dependent upon the p-value. So what this involves is just coming over here and using these four in these calculations. So our y max is 1. Our y min is negative 1. So this is 2 over 2, which is 1. Now, you didn't need to do that because what is the A is the amplitude, absolute value of A. And that's the height of either half. The way that I have this set up, your A will always be positive. Something you need to know. Depending on who your teacher is or what textbook you're looking at, there are many answers for a particular sine or cosine wave. There's an infinite number of them. So this is just one way. It's a way that always works, and that will generate a correct answer. Okay, B, and this is the hardest part of this to calculate because it involves the having to deal with the pi constant and then trying to treat it like a variable. So x max minus x min. So pi minus pi over 2. 1 minus 1/2 is 1/2. Just do the fraction part. And to save time in this video, I'm not going to get on my calculator and show that. But you do 1 minus 1/2, you get 1/2. So that's pi over 2. So you're going to get a fraction on the bottom of this. And so what that involves is flipping and multiplying. And you should get a nice whole number answer for this. So B is the hard part here. Got to make sure you get that right. Now we're doing h sub sine so we don't do this because it's not a cosine. X min plus x max over 2. So now you have to add these. 1/2 plus 1. Okay, 3/2 over 2. Okay, so this ends up being 3/4. So you get 3/4 for an answer, and then you put a pi there. So, all right, I will show it once. So you have 1 plus 1/2, or you could say 1.5. Whoops. I even messed that up. Over 2. Okay, so That's a little bit of work from time to time also. If you have some, you're just then putting the pi back in. Same way up here, 1 divided by 1/2. That you don't put the pi back in because it cancels. Just be careful when you do these that you do them correctly. So you should see on the h sub sine, you're going to see some pi's in that. You're not going to on a and b. K, you're not going to see because that's the vertical shift. So y min plus y max over 2. So I need to say this. Why do you see pi in the answer of h? Because h is a horizontal shifting. And we know that the x-axis, although you don't see it here because I printed these without like doing them by hand, the x-axis is the unit circle, even though it's not set up because you don't need those points on this assignment. You just need a min and a max. The h is going to have pi's in it. The a, the b, and the k will not. Is it possible to have pi in those? It is. Okay, so there's our period pi. You can see that. That's one complete cycle. So where does it, you start here where it starts going down. Where does that start to happen again after a length of pi? There it is. You have it. How do you write it now? So the 1 is in front. You don't need to put 1 times sine. I'll write it this time just so you can see everything. And then the b is 2, x minus 3 pi over 4, and then 2 parentheses plus 0. So this was a times sine of b times x minus h plus k. That's what you're doing, sine or cosine, every time. And we're looking for this. So speed up. I'm going to get these, talk a little bit about them, go through these pretty quickly, and then generate the equation. And you have 8 of these to do because they do require a little more practice. All right, number 2. So we want a cosine equation. Now you don't have to have the min to the left of the max, but be very careful. Some of these are, -3 here. I didn't mean to try to fit that all in there. Be careful that you get the min in the min position and the max in the max position. Okay, so sometimes the min comes second. Just be very careful. If you don't get those right, it's all over. You might as well just not do it. So slow down. This is your max. That's a peak point. This is your min. Okay, and then you can go and calculate these. You can see that this is going to be 3. Okay, and you can see that the midline is k. The a and the k are easy. What's the amplitude? What's the height? 3. Where's the midline? Through 0. It's the b and the h. Actually, h with sine. H with cosine is going to be easy. So you see this. H sub cosine equals the x value at the max. So this is pi over 12. Done. You just pick it. That's it. And then the b calculation. So pi over the x max minus the x min, and that's absolute value. So you make it positive. So it's 1 over 1/12 minus 7/12 absolute value. Okay, so we'll just make it positive when we do it. So 1 over 1/12 minus 7/12. So you got to really learn how to maybe use your fraction tool a little bit. And we're going to make it positive. Remember, you got to get a whole number. But this is not going to be anything with pi in it. This is 2. You're going to get a nice answer. That's what's nice. And then we're not doing that because we're not doing sine. All right, we have it. 3 cosine of 2 times x minus pi over 12 plus 0. Again, getting used to where all the parentheses go. and having to do this. Just be very careful with your B calculations and sometimes your H calculations with sine. It's a fraction tool. You know, if you don't want to use your fraction tool, I'll show this one time. This is what you have to do, 1/12 minus 7/12, like that. So that is a little easier. It will do it. And you're going to get something nice, a pretty nice answer, because I've worked them out to have these values that are common. And so 2 pi over b. So this again will be pi, 2 pi over 2, absolute b, will be the period. All right, number 3. Graph of sine again. So again, we have to get this. Now the problem is, this is the hardest one on here. I don't ever want to back away from things hard. You won't have one that's hard. It's all the same procedure, but you got to turn things into 12. So this is 9 pi over 12. Common negative 0.5. So you added 8 pi over 12. So we need to add another 8 pi over 12. So this is 17 pi over 12, comma, negative, positive 0.5. Now, the reason we needed to get that, because we want a sine graph, and when you do a sine graph, listen to me. When you do a sine graph, the min needs to be the left of the max. Okay? Out and out, that's what you need to do. So our x min, y min, 3 pi over 4, negative 0.5, and then max 17 pi over 12.5. All calculations are the same, and I'm going to go quickly through this. 0.5, the k is the midline. That's easy. A and k are fast. Oh, they're fast. B, 3/2. 1 over 17/12 minus 3/4. Can you do it like I showed you? 1 over 17/12 minus 3/4. The pi is in there. We're just taking it out of the calculation, okay, because it cancels out like I showed you before in the original problem. But I want to save time and quickly go through this. So we're not doing cosine, we're doing sine. X min plus x max over 2. So you're doing 3/4 plus 17/12 over 2. I'll do it. Okay, so you have 1.008, then you got to convert that. So there's a lot of fraction work with this. 13/12, so 13 pi over 12. This is a hard one. It's just the values I didn't pay enough attention to as I did this. So 0.5 sine of 3/2, which we'll call that 1.5, x minus 13 pi over 12 plus 0. So what was different about this? A crazy shift of 13 pi over 12 to the right, and then we have a small amplitude, so it took it down from an amplitude of the standard amplitude of 1, and then we stretched it because we increased b from 1 to 1.5. So that's what happened. All right, so the period 2 pi over b. So 2 over 3/2 is what you're doing. We're at that. That's 4/3. So 4 pi over 3. It's all about keeping the pi out of the calculation when you do that. That's a hard one. Okay, problem 4. And again, I'm slowly going to start moving very quickly. So 0, negative 3 is our x min, y min, and then pi, negative 1. And we don't need to worry, the min is to the left of the max, so we're good. This is 1 and 1. We're not doing this. This is pi and negative 2. So remember, depending on what kind of graph you're doing, that's whether you choose the h sub sine or the h sub cosine. The a, b, and the k are the same regardless of whether you do sine or cosine. This is 2 pi. All right, so our equation will be 1 times cosine of 1 times x minus pi plus negative 2. So for the first time here, we had a shift of 2 down. That's the midline. I drew a midline through negative 2. Okay, don't forget the K value is the midline. And it's always easy to get A and K. You can get it by looking at the graph. So if I could get my ruler back here, I did with my ruler. You know, if I drew the midline through this for a little ways, the height, you know, above and below, that's your amplitude. It's really easy to get A and K. Okay, problem 5. So again, we don't have, this is going to be pi over 3, 1. And since we're doing a sine equation, we need that max to be to the right. So pi over 6, -1, pi over 3, 1. A, B, H, and K. So you can see 1 and 0. That you should be able to get, and I mean right now. And B is 6, and then H sub sine is going to be pi over 4. Again, with all the same, you know, 1 over 1/3 minus 1/6. Keep the pi out of the calculation. That will give you the 6. And then x min plus it. So 1/6 plus 1/3 all over 2 will give you 1/4. Then you put the pi back in the calculation. Okay, so validate that every time. This will be 2 pi over 6, which is pi over 3. All right, so equation time. 1 times sine, that's what we wanted, of 6 times x minus pi over 4, 2 right parentheses, plus 0. So we increase the b value, which I told you scrunches up the graph. It compresses it. In the A, we have a standard amplitude of 1. Okay, problem 6. Stretched it out a little bit here. We do want a cosine, so we're good with this. Make sure you're understanding, there's my coffee maker, you're understanding the min and the max. The min is the lowest point, the max is the highest, the bottom of a wave, top of the wave. If you get that wrong, it's no good. So A, you should be able to see is 1, and K is 0. And we're doing a cosine equation, so we don't want sine. So B is pi of 1 over -1/4 plus -5/4. I'll do that this time. 1 over -1/4 minus 5/4. We got to make it positive, though. We're keeping the pi out of the calculation. It cancels out. Don't forget that. Remember, we're making it positive, too. So 2/3. It's a little goofy. And then x max. You just pick the x max value. Cosine's easy because you just pick the x max value. That's all you choose for the h. So what does this look like? 1 times cosine of 2/3 times x plus pi over 4, because you're subtracting pi over 4, which makes it a plus. There's the graph. Notice that the b value got smaller, which stretches the wave. And the amplitude's still 1, but it stretched the wave. Okay, so 2 pi over b, 2 over 2/3 if you want. You're going to do the same thing. Is 3, so 3 pi. So make sure you get those entries right when you're dealing with fractions. Leave the pi out of the calculation. Sometimes you have to put it back in. So for the h, you'll have to put the pi back in the calculation. Problem 7. So we want a sine graph. So we're going to have to go here. And this will be, so this is 6 pi over 12. So we added 7, and this is -2 pi over 12. This is 6 pi over 12. So we added, it looks like we added 8 pi over 12. So this one up here is 14 pi over 12. So I'll write that above it, comma 0. So this is 7 pi over 6 reduced. Now that is a little hard to get. That's the challenge on this problem, to get that, because we're doing a sine graph. The min has to be to the left of the max. So the min, pi over 2, -2, the max, 7 pi over 6, 0. Okay, so it's important that you get that max to the right of the min, or min to the left, however you want to look at it. So A, again, this is very simple. You should do K first. K is the midline through -1. Where's the middle of the graph? There's my ruler. Where's the middle of the graph? It's through -1. Or to make sure, do y min plus y max over 2. And then half the height of the wave is the amplitude. You can get A and K right away all the time. So 1 over 7/6 minus 1/2. 1.5. And remember, the pi's drop out. So don't forget, I'll write this one out. The pi's are canceling out. So this on the bottom is 14 pi over 12 minus 6 pi over 12 is kind of like saying 8 pi over 12. And then so 12 is going to be on top, 8 pi is going to be on the bottom. And the pi's drop out. So I'm just trying to say that the pi's always cancel out, but you can just enter it in without the pi's. And then h sub sine, we're going to do 1/2 plus 7/6 divided by 2 and put the pi back in. So 5 pi over 6 is the h value. A little goofy there, but doable. And then this will be 4 pi over 3. So 2 over 3/2 is what you're doing here. Put the pi back in. So a lot of fraction work with this because of how the unit circle is set up. So this will be 1 sine of 3/2 times x minus 5 pi over 6 plus -1. Now in time, you don't have to put the ones in. I'm just showing you structurally how to do this, so that every time you can get an equation for a sine or cosine graph correct. Realize that, that's why I gave you a little bit more today. Realize that there, depending on the textbook, this, how you represent it can change. All right, so cosine, we're good here. Negative pi, -2, and then pi 2. And so just the x max, that's always easy to do. I really like it when we find the equation of a cosine function, because you just pick the x max value. That's it. And then b is 1 over 1 minus -1. That's 1/2. So, yep, literally 1 over 1 minus -1. So you take the pi's out of it totally because they cancel, and it's just 1 minus -1. So x max is pi, x min. Literally, I mean, if you just are a person that literally needs to do everything, you can actually, oh, whoops. Okay. You actually, on B, for the value of b, this needs to be pi, you can actually do it with pi in there if that you literally wanted to do it. It's just that when you do the h sign here, you're going to have to leave pi out. All right, so 2 cosine of 1/2 times x minus pi, 2 right parentheses plus 0. Okay, and then this will be 2 pi over 1/2. This will be 4 pi. 2 over 1/2. Okay, and then that's the end of this. And now you have 8 problems to do. Just be careful over here. There is a way to graphically check on your calculator. Okay, and I'll just show one of those really quickly. So 2 cosine, you literally put it in like you see, x minus pi, 2 right parentheses. Okay, you could put plus 0 if you want. Now, when you set this up, I'm going to go by degrees. So your delta table, you would have to remember and look that up. It's pi over 2 times absolute b. So your delta table would have to be 2 times 1/2 is 1, would have to be pi, which is 180 degrees if you wanted to do this. Okay, and then you got a zoom trig to do, and you should be able to see it. So you're on this just because you're not stretched out enough. All right, so I made a little mistake there. That's why I had to pause the video. If you enter your H value in terms of the way we figured on this assignment, you have to be in radians mode. So I had everything in degrees, but if we're going to use pi, when we do our table set, it has to be 0, and then the delta table has to be pi instead of 180, and then you got to go to radians mode. Why? Because of the pi in the, and then it will look like, so you saw the previous graph I had wasn't correct, because I had the pi in the equation, and then I had it in degree mode. So make sure that you know, either way. So we could come back here and put 180 in, which would be really strange to do, by the way. And then we could go to our table set 0 by a step of 180, then change our mode to degrees. So this is why it's better to, and then you do a zoom trig. There's a lot of hoops to jump through. This is why it's better to stick in probably radians mode when you're checking your work with this. Stick in radians mode, and then it just doesn't show the right hand part of this. Okay, so you have your assignment to do.